Hey guys, today we will be doing a video in which we will go over a physics P5 paper. And the reason I'm doing this video is because a lot of students, including myself until some time ago, had difficulty grasping how to proceed with the first question of this paper, which has a total weightage of 15 marks. And this question had a lot to do with identifying the primary variables of an experimental scenario and outlining the procedures you will carry out and the measurements you will take in order to get the necessary data via whose analysis you will be able to figure out the relationship between two variables mentioned in the experimental scenario. So we will do one such question, and along the way I will tell you some key points that you must know, and knowing which will help you do many of these questions. So the question statement is: a ball rolls forwards and backwards on a curved track as shown in figure 1.1. So it is rolling forwards and it is rolling backwards. So this might be the equilibrium point, and from reading even the first part of the question you get the idea that perhaps this experiment has something to do with simple harmonic motion. It's just a gut idea, not anything concrete. Let's continue with the statement. And it is suggested that the period T of the oscillations, and what is the period? Is basically the time taken for one complete oscillations. That would be when the ball is here, it goes over there, returns, then goes over there and returns, and the total time for one such complete event would be the time period. And the suggested relationship is that the period T of the oscillation is related to the radius r of the ball and the radius of the curvature of the track by the relationship. So the time periods may be related to two quantities. And what are the two quantities? The radius of the ball and the radius of the curvature. And what does that mean? Well, it means that if this was the curvature and this was the ball, then this value as well as this value would potentially have an impact on the time for one complete oscillation. So if we were to change the value of this or the value of this, there would likely be an impact on the value of the time period. And at this point, this is just conjecture. This is a suggested relationship which we have to either validify or make invalid or prove invalid. And what is this? And what is the suggested relationship? T square 28 pi square over 5g c minus r. Alright, where g is the acceleration of free fall. Something to note: g is a constant, pi is similarly a constant, and 28 over 5 is obviously a constant. So this part of it is basically constant. So we can write this as t square is equal to 28 pi square over 5g, and all of this is basically multiplied to this difference between the curvature of the track, the radius of the curvature of the track, and the radius of the ball. And since all of this is constant, we may represent this as t square is equal to k multiplied by c minus r. Again, conjecture, thought process while you're reading through this question. And you are provided with a flexible track, alright? And we have to design a lab experiment. And what is the purpose? We have to test the relationship between t and r, not t and c, or t and c and r, t and r. Alright? So, what we want is the relationship between t and r, meaning potentially this and this. And we have to explain how the results of the experiment we designed would help us determine a value for c. And you should draw a diagram showing the arrangement of your equipment, alright? And you should pay particular attention to procedure, measurements, variable control analysis, and safety precautions. Remember, this is a 15-mark total question. Right, so the first thing to do with such a question is to identify the types of variables. And there are 3 types of variables: independent, dependent, and controlled. And an independent variable is the one that we change in order to observe a change in some other factor. And the factor in which we will observe such a change is the dependent variable. And the third variable type is the controlled variable, and is a variable that would potentially have an effect on the dependent variable should its value be changed. And therefore it is something we keep constant in order to see that any variation in the dependent variable is due to the independent variable alone. And from all of this, it is pretty clear that c would be the controlled variable. And as for t and r, which do you think is the independent variable? It would most likely be the radius, because we can easily change the radius and observe a corresponding potential change in the time period, and therefore dependent variable is the time period. And these are 3 solid marks. And what procedure would you follow? Well, number 1, you would use the same flexible track for all of the experiments you will carry out. Number 2, you would use at least 5 balls of varying radius. And as you can observe from the equation, that it is likely that increasing the value of the radius would most likely decrease the value of the time period. And this is just conjecture at this point, right? Because this is c minus r, and if you could, like, t square is equal to kc minus kr. So if this is constant, and if we increase the value of this, then basically this would decrease, and so would the time period. All right, and so we want a value of the time period that is substantial, so that we can, so there is a less experimental error when we measure it. So we can use balls whose radius is small. All right, because we want a substantial value for the time period, and we want equal intervals between the radius of said balls. And if we want to measure the radius, it would be better if we use a micrometer screw gauge, because it has a lot of accuracy. It is very accurate to about 0. plus minus 0.01 millimeter. And how do you observe the time period? You could use a motion sensor, or you could record and then play back frame by frame, and use a recorder which has an incorporated internal timer. Now these are possibilities, and you can basically figure out the time intervals for, say, 10 oscillations, and then divide by 10, so you would know the value for one time period. And another thing is that we want the flexible track to be relatively smooth. We want that there isn't a lot of friction, and that the surface is smooth, and that the amount of friction and the smoothness is more or less constant. So you can carefully wipe the flexible track in between each experiment. And this is and the measurements, again, I've told you, and the analysis of the data. So now you have values for the radius, which you got from micrometer screw gauge, and you similarly have values for the time period. And as for C, you can also figure that out, because you want a value for C as well, don't you? Because this is part of the experiment. How do you do that? You could do this. Yep. So basically, if you were to draw a line over here, this distance would be the radius, and therefore to measure it, we could simply measure the distance between the two ends of the flexible track and divide it by 2, because this and this will be equal, and this is a property of circle. And when it comes to analysis of the data, how do you think we should proceed? Because from the equation, it is pretty clear that if you were to plot t square against r, you wouldn't get a straight line graph, and any graph would likely be curved, and therefore it would be difficult to figure out the exact relationship between the two quantities. Right, so we want to get a straight line graph. And how would we get a straight line graph? So as we know, the equation for a straight line graph is basically y is equal to mx plus c, and we want all of this to be in a similar, in a similar format. So the equation given is t square is equal to, as we mentioned, k into bracket c minus r, and if we were to remove the bracket, we would get kc minus kr. Another thing to note is that when we draw a graph, we keep the independent variable on the x and the dependent on the y. So if we were to plot, say, radius against t square, for example, because we want the relationship between them, don't we? Then r is obviously the x, and y is equal to mx plus c. And if we are comparing all of this, this would mean, what would this mean? That this and this are analogous, and this means basically that mx is equal to minus kr, and because r is equal to x, and the gradient would be equivalent to k. Alright, and it also means that this and this are analogous, and so is this and this, and therefore we draw a graph of t square against r, and if we get a straight line graph, then we know that the relationship that was given in the question statement is valid. And this is basically analysis of the data part of it. And how do we figure out the value of c? As mentioned previously, there are a few things that seem to be analogous, and what are this? The y-intercept is equal to k into c, and therefore capital C, what we want is the y-intercept divided by k. And what is k? K is basically the gradient, because from here it is clear that it is the gradient. Minus k is equal to m. So k would be minus m most likely. So c is equal to y-intercept divided by minus the gradient given, minus the gradient we actually have, and therefore we would actually have a positive value, because most likely we would have a negative gradient straight line for a valid relationship. So any safety precaution you should take. The ball might likely be heavy, and so you want to maintain a distance, so in case the ball falls off, it doesn't hit you. A screen might be helpful. Another thing is that we want the ball to follow the same trajectory, and therefore we have to release it carefully. All of this should be with the 15 marks given. Let's see the marking scheme to see if we missed out something and any potential improvements. And we should also take a look at examiner report. A lot of students don't pay a lot of attention to the examiner report, but that is a pretty stupid thing to do, because maybe they don't realize just how important examiner reports are. They give you quite the idea of how to proceed. Yep, r is the independent variable and t is the dependent variable, and we have to keep the radius of the curvature constant. 3 marks given. Method of data collection. We have to show a diagram showing ball in a curved track with supports for trap. Example, retort stand, minimum of 2 stables. Right, measure time using stopwatch or light gates and timer, or data logger with motion sensor. That is what we did. Data logger with motion sensor, or detail needed for video camera. And then we have to use many oscillations and determine, measure diameter with a micrometer screw gauge. Again, radius is diameter over 2. Again, 1, 2, 3, and 4. Plot a graph of t square against r, and c would basically be the y-intercept multiplied by this, or the y-intercept divided by the gradient. Again, marks. And precaution linking to ball escaping onto the floor. Example, use barrier safety screen 1. Again, so keep the weight, add weights to the G-clamp retort stands. This is something I didn't mention, and you might lose marks for this. 1 mark. And material density of the ball constant. Fiducial marker near center of track, mark on the track. I did mention this, that some method to see that the trajectory is constant. Clean track and balls, again mentioned. Repeat measurements of T and average. Repeat measurements for D and average. Relationship is valid if straight line, mentioned. So 3 marks definite over here. So most likely from 15 you would have gotten 13 or 14 if you had presented this answer. So again, let's go with this. Never forget to identify the independent, the dependent, and the controlled variable. They are equivalent to a total of 3 marks. And mention how the exact procedure. Right, so saying, so first of all we have to outline the way in which we will measure any variation in the dependent variable, and since this time we're talking about the time period, there are a number of different options. The video camera one, but we'd have to provide details about how there has to be a timer incorporated with the video camera and how we would have to use the frame by frame playback option, because otherwise we wouldn't be able to identify the individual oscillations. We could also use the simple method of measuring time with a stopwatch, but that has a lot of inaccuracy. We could use light gates that automatically start or stop the timer when the ball passes through a certain point where the light gate is located, or you could use a data logger with motion sensor. And this is important, and also we should have a diagrammatic representation of the experimental apparatus, and often the diagrammatic representation has to have some certain things included which we don't normally mention in the experimental procedure because it is kind of obvious, but we should show, for example, supports for the track. Obviously the track isn't suspended in thin air, but that isn't something that is exactly part of the procedure, but it is there. So in the diagram, if you mention it, you'd get the mark. And you have labeling is something you should do as well. For example, you could label the ball, the track, the supports, but not the stopwatch, the bench, or the micrometer, because those aren't exactly part of the experimental setup itself. And this supports making contact with track higher than ball. Kind of obvious. And use many oscillations and determine capital T is equal to T over N. Again, this is for the sake of experimental accuracy in determining the dependent variable. If any such possibility exists, you should measure it. And we have to measure the diameter or the radius of the ball with the micrometer or the vernier caliper. Again, you should know how we measure the independent variable. Radius is equal to diameter over 2, and this is kind of obvious. And analysis of the data, we have to basically have it in a straight line format. And again, the figuring out the value of the C, and the precaution is mentioned, whether it is possible that the ball might leave the track and hit you straight in the eye. And additional details as mentioned, add weights to the retard stands basically for greater stabilization of the track. You should keep the material, the density of the ball constant. This is obvious. I'm really unhappy that I missed this out. Use a fiducial marker near the center of the track. I mentioned this sort of when I said that the trajectory ought to be constant. We should have a clean track and ball for friction reduction, because otherwise it would dampen the oscillations. We have to repeat measurements for T and average, and repeat measurements for D and average. Again, if you mention this, you get a lot of marks, and this is pretty much the same all the time. Relationship is valid if straight line, again, is valid if straight line does not pass through the origin. Again, it is mentioned that we do in fact have an y-intercept. And this is it. Let's take a look at the examiner report. #51. Yep, 51 general comments. Typical lab experiment, technique of measuring time periods, variable identification and constants from given equation and details, radius as the independent variable, ignoring the track altogether. Graphical analysis would still benefit. Alright. Time period and correct identification of independent variable was radius of the curvature. Again, that was a pretty stupid thing. Perhaps suggesting that they had read the questions incorrectly. Credit for controlling the variable, keeping appropriate variables constant, and method of data collection. Labeled diagram for this investigation needed to include a method for supporting the track. Time period and the radius were measured. How much time it would be measured. How period would be determined from timing many oscillations, micrometers, repeating and averaging the time period. Additional detail, G clamps for more stability had to be of the same density material, cleaning the track and the ball to assist with counting the number of oscillations. This is it. Hopefully this was helpful. If you like this video, please like and comment. Hopefully I'll make other similar videos about the P5. If you want them, please mention in the comments.